Okay, first question. Okay, first step is to move the negative 8 to the left-hand side. And it becomes positive 8, right? And this is greater than 0. And then rewrite the whole expression using the common denominator, which is 6x minus 2. Of course, do not forget the equivalent symbol here. Okay, and then let's reorganize the numerator. 5x plus 3 plus 8 times 6x is 48x. 8 times minus 2 is minus 16. And common denominator is 6x minus 2, right? And the whole expression should be greater than 0. And this is equivalent to, let's simplify the numerator, which is 5x plus 48x is 53x. 3 minus 16 is minus 13, right? And over 6x minus 2, which is greater than 0. And then you have a ratio that is greater than 0, right? And this is equivalent to the symbols, the signs in front of the two numbers, in front of the numerator and denominators should be the same, right? So they could both be positive or both be negative. So this is equivalent to both the numerator and denominator are greater than 0, or both of them are negative. And this is equivalent to, let's solve them separately. The first one gives you x should be greater than 16 over 53. And then x should also be greater than 2 over 6, which is 1 over 3, right? Or x is less than 13 over 53. Or and x should also be less than 1 over 3. And then we need to consider which number is greater, right? Note that 13 over 53 is about 0.2 something, right? And 1 over 3 is about 0.3 something. So 1 over 3 is greater than 13 over 53. These are the relative positions of the two numbers. Okay, so this is equivalent to when x is greater than 13 over 53, and also x should be greater than 1 over 3. The combination of these two is x should be greater than the greater number, which is 1 over 3, right? And if x must be less than 13 over 53, and at the same time x should be smaller than 1 over 3, x should be, the combined result is x should be smaller than the smaller number, which is 13 over 53, right? So this is our final result. Final result is x is either greater than 1 over 3 or less than 13 over 53. Okay, any questions? No? Okay, let's see question 2. Okay, again, question 2, you can't just multiply 4x minus 7 to both sides because we don't know the sign in front of the denominator, right? We don't know whether it's positive, negative, or 0. So we need to move the 8 to the left-hand side and rewrite the whole expression using the common denominator. Okay, so the original expression is equivalent to this one. When 8 is moved to the left-hand side, it becomes minus 8, right? And this expression should be greater than 0. And then rewrite the expression on the left-hand side using the common denominator, which is 4x minus 7. Okay, 4x minus 7 over 4x minus 7 above 0. And then reorganize the numerator, which is minus 3x plus 6 minus 8 times 4x is minus 32x. And minus 8 times minus 7 is plus 56, right? And over the common denominator, which is 4x minus 7. Whole expression should be greater than 0, okay? And this can be simplified to minus 3x minus 32x gives us minus 35x, and plus 6 plus 56 gives us plus 62, right? Over the common denominator, which is 4x minus 7, which is greater than 0. And again, we come to a point that the ratio between two numbers is a positive number. So that means this is equivalent to either two numbers are positive at the same time, or the two numbers are negative at the same time, right? So it's equivalent to minus 35x plus 62 greater than 0. And at the same time, the denominator is also greater than 0. Or the numerator is less than 0, which is a positive number. And at the same time, the denominator is also a negative number, right? So the ratio between two negative numbers is also positive. Okay, so this is equivalent to x is smaller than 62 over 35, and x should also be greater than 7 over 4. This is derived from the first branch, right? Second branch, we have either x is greater than 62 over 35, and at the same time, x should be less than 7 over 4, right? Next, we need to compare these two numbers, which is larger. Note that 62 over 35 is about 0.1 something something, right? And 4 over 7 is also 62 over 35 is 1 point something. 7 over 4 is exactly 1.75. So we need to calculate more of the first number. 62 over 35 is actually 1.771 something here. So which number is larger? Of course, the first number is larger, right? So first number is here, and 7 over 4 is about here, right? Okay, so as long as we know the relative positions of the two numbers, we can find final solutions. First of all, the first branch says x should be smaller than 62 over 35 and greater than 7 over 4. So x should be within this interval, right? Okay, so that means x is within this interval. And the second branch says x is greater than the greater number and smaller than the smaller number. So there is no overlapped area. That means there is no solution for the second branch. So x belongs to an empty set. So considering both the two branches, final solution is x should be smaller than 62 over 35 and greater than 7 over 4, right? This is our final solution here. Okay, please have a look at this. Any questions? No? Okay, let's proceed to the next one. Question 3. Okay, again, we can't just multiply 5x minus 7 to both sides because we don't know whether it's positive or negative. So let's move the constant 9 to the left-hand side, which becomes minus x plus 8 over 5x minus 7. And if you move a number to the other side, it becomes positive. Positive number becomes negative, right? So negative 9, less than 0. And then, of course, the common denominator is 5x minus 7. So this expression is equivalent to minus x plus 8 over 5x minus 7 minus 9 times 5x minus 7 over 5x minus 7, which is less than 0. And this is equivalent to minus x plus 8 minus 9 times 5x, which is 45x, and minus 9 times minus 7, which is plus 63, right? Over the common denominator, which is 5x minus 7, less than 0. And this is equivalent to, let's simplify the numerator now, minus x minus 45x, which is minus 46x, right? And plus 8 plus 83 is 80, plus 8 plus 63 is 71 over the common denominator 5x minus 7, less than 0. Okay, again, a ratio between two numbers is a negative number. This is equivalent to either the numerator is negative and at the same time the denominator is positive, right? Or you can also have the numerator is positive and at the same time the denominator is negative, right? Okay, so let's solve these two branches. First branch, sorry, I lost x here, minus 46x, right? So x should be first greater than 71 over 46. And x should also be greater than 7 over 5, right? Or from the second branch, if you move minus 46x to the other side, that means 71 is greater than positive 46x. So x should be smaller than 71 over 46. And at the same time, x should be smaller than 7 over 5, right? And again, we need to compare which number is greater. So 71 over 46 is around 1.5 something. And 7 over 5 is exactly 1.4. So which number is larger? You can easily tell that the first number is larger, right? So 71 over 46 is here, and 7 over 5 is here. Okay, so this is equivalent to first branch tells us x is greater than either number. Oh, sorry, x should be greater than both of the two numbers, right? And the combined result is x, the overlapped area is x should be larger than the larger number, which is 71 over 46, right? Or the second branch tells us x should be smaller than both of the two numbers. And the combined result, the overlapped area, is of course x should be smaller than the smaller number, which is 7 over 5, right? Okay, so this is our final solution to this question. Okay, please have a look at this. Do you have any questions? No? Okay, let's see question 4. Question 4, again, we can't just multiply x minus 4 to both sides, right? Because we don't know the sign in front of x minus 4. So basically, we need to move this expression on the right-hand side to the left-hand side and rewrite the whole expression using the common denominator, which is x minus 4. Okay, so following this logic, the original expression is equivalent to 16x over x minus 4. And then we can just put the minus x plus 4 to the left-hand side, which becomes plus x minus 4, right? And this should be less than 0. And this is equivalent to 16x over x minus 4 times x minus 4 less than 0, right? And this is equivalent to 16x plus x minus 4 squared over x minus 4, right? Smaller than 0. And let's try to simplify this. 16x. Remember, there's a formula to expand the expression here, right? X minus 4 squared is plus x squared minus twice of x and minus 4, which is minus 8x, right? And plus minus 4 squared, which is 16. Remember the formula? Okay, over x minus 4 should be smaller than 0. And the numerator now is x squared plus 8x plus 16, right? Over x minus 4 smaller than 0. And remember that this is actually a formula, right? This is actually x plus 4 squared. Remember that? So this is equivalent to x plus 4 squared over x minus 4 less than 0. Okay? And we know that the ratio of two numbers is smaller than 0, which is a negative number. This is equivalent to either the two numbers, the sign in front of the two numbers should be different, right? So either we have a negative numerator and a positive denominator, or we have a positive numerator and a negative denominator, right? And this is equivalent to first branch is x plus 4 squared is a negative number. So this cannot happen, right? There's no solution. There is no x, no such x that can satisfy this expression because something squared must be above or equal to 0. It cannot be less than 0, right? So, of course, there is no solution for the first branch. So x belongs to an empty set. How about the second branch? Second branch, let's first solve this one. X plus 4 squared is above 0. We know that a number squared is above 0 or equal to 0, right? So as long as it is not 0, that means as long as x is not minus 4, this expression squared must be greater than 0, right? So this is a solution to this. Understand? I know that some of you have done this wrong. Do you understand now? Any questions? Hello? Okay. How about the second one? X minus 4 is less than 0. This is equivalent to x should be less than 4, right? Okay, so let's combine these two results. First result is x belongs to an empty set, or the second branch says x should be less than 4. And at the same time, x cannot be minus 4. So the final result is x should be less than 4 and x cannot be minus 4. Understand? If you draw a diagram, it should look like this. This is 4, this is minus 4. X should be less than 4, but cannot be minus 4. So you need to remove this point here. Okay? Please have a look at this. Any questions, let me know. No questions? Okay, let's see the next one. Okay, next one. This time the inequality is not strictly greater than or strictly less than, but this time we have a equality symbol here, right? So the difference is when we consider a question like this is equivalent to actually 3 branches, right? Okay, let's have a look at this. First of all, again, let's rewrite the whole expression using the common denominator, which is 8x plus 7. Okay, when you move 6 to the other side, it becomes minus 6, greater than or equal to 0. And rewrite the expression on the left-hand side using the common denominator. Okay, and this is minus 6 minus 9. Minus 6 times 8x is minus 48x. And minus 6 times positive 7 is minus 42. Over common denominator is 8x plus 7, greater than or equal to 0. And if we simplify this, minus 6 minus 48x is minus 54x. And minus 9 minus 42 gives us minus 51, right? Note that there is a common factor 3 in these two numbers, so we can further simplify this in our next step. So next step, we can just divide both sides using a 3, right? Because 3 is a positive number, so we don't need to change the direction of the inequality symbol. So minus 54x divided by 3 is minus 18x, right? And minus 51 over 3 is minus 17 over 8x plus 7, greater than or equal to 0. Okay, and this is actually equivalent to, first of all, the ratio here can be 0, right? It can be 0. Or it can also be greater than 0, right? So we have 2 branches here. And next step, if we have a ratio that is 0, this is equivalent to the numerator must be 0. And at the same time, the denominator cannot be 0, right? Or, okay, we have already know how to solve this, right? If you have a ratio that is strictly greater than 0, this is equivalent to the signs in front of the two numbers must be the same, right? So that means either we will have a positive numerator and a positive denominator, or we can have a negative numerator and at the same time a negative denominator, right? Okay, next step, you need to solve the 3 branches separately. First of all, x is minus 17 over 18, but x cannot be minus 7 over 8, right? Or second branch is x must be smaller than minus 17 over 18. Careful with the numbers and direction of the inequality symbol here, right? Do not confuse them. Second, x must be greater than minus 7 over 8, right? Or the third branch, you must have x is greater than minus 17 over 18, and x must also be smaller than 7 over 8, right? Okay, now we need to consider the two numbers here. minus 17 over 18 or minus 7 over 8, which is larger? Okay. First of all, minus 17 over 18 is about minus 0.94 something. And minus 7 over 8 is exactly minus 0.875. So which one is larger? Of course, minus 7 over 8 is a larger number, right? So if we draw let's draw the number axis here. We draw number axis. This is minus 7 over 8, and this is minus 17 over 18. Okay. All right. So if we know the relative positions of these two numbers, let's find a solution. First of all, x can be minus 17 over 18, right? Second branch says x is smaller than the smaller number and larger than the larger number. There's no overlapped area, so there is no solution in the second branch, right? So in the second branch, x belongs to an empty set. Or we can also have the solution. Third branch says x is greater than the smaller number and smaller than the greater number. So this is, of course, the overlapped area, right? So the third branch says x must be smaller than minus 7 over 8 and greater than minus 17 over 18. Okay, so if we consider all of the three branches, the final solution should be x must be smaller than minus 7 over 8 and larger than or equal to minus 17 over 18. You get that? Okay, this is our final solution. Came all the way here. Okay, please have a look at this. This is our whole reasoning process. No questions? All right, let's see the next one. Question 6. Okay, following similar process. First of all, let's move 2 to the other side, which becomes minus 2, right? Okay, sorry about this. Okay, question 6. Original inequality is equivalent to minus 3x plus 2 over 7x plus 3 minus 2 less than or equal to 0, right? And then let's rewrite the expressions on the left-hand side using the common denominator, which is 7x plus 3. Okay, and then expand the numerator and simplify. Minus 3x plus 2 minus 2 times 7x is, of course, minus 14x, right? And minus 2 times 3 is minus 6 over 7x plus 3. This should be less than or equal to 0. And this is equivalent to minus 3x minus 14x is minus 17x plus 2 minus 6 is minus 4, right? Over common denominator is 7x plus 3 less than or equal to 0, right? And this is, of course, again, is equivalent to either this ratio is 0. Okay, we need to detach the equation with the inequality, or the ratio here can also be smaller than 0, right? And next step, a ratio that is 0 means the numerator must be 0, and at the same time, denominator cannot be 0. And for the inequality, if the ratio of two numbers is a negative number, this is equivalent to the sign in front of the two numbers must be different, right? So either we have a negative numerator and at the same time a positive denominator, or we have a positive numerator and at the same time the denominator should be negative, right? Okay, and now we need to solve these three branches separately. First branch gives us x should be negative, x should be exactly negative 4 over 7, and x cannot be minus 3 over 7, right? Second branch is x must be larger than minus 4 over 17. And at the same time, x should be greater than minus 3 over 7. Third branch. First of all, x must be smaller than minus 4 over 17. Second, x must be smaller than minus 3 over 7. Now we need to compare the two numbers again, right? So minus 4 over 17 is about minus 0.2 something something. And minus 3 over 7 is about minus 0.4 something. So which number is larger? If we draw a number axis here, minus 4 over 17 is apparently larger, right? Okay, so these are the relative positions of these two numbers, which can help us to decide the final solution. So this is equivalent to, first of all, x can be minus 4 over 17. Second branch, x should be greater than both of the two numbers. Combined result, overlapped result is x, of course, should be larger than the larger number, right? Which is minus 4 over 17. Okay, third branch. Third branch says x should be smaller than both of the two numbers. Of course, the overlapped area is x should be smaller than the smaller number, right? So x should be smaller than minus 3 over 7. So considering these three branches, the final result is x should be greater than or equal to minus 4 over 7, or x can also be smaller than 3 over 7. Understand? Okay, please have a look at this. If you have any questions, please let me know, okay? questions? All right, let's see next one. Question 7. Okay, again, let's move. First step, let's move -9 to the other side, right? Original expression is equivalent to 3x minus 8 over 7x plus 6 plus 9, right? Greater than or equal to 0, which is equivalent to, let's rewrite the expression here using common denominator. Plus 9 times 7x plus 6 over 7x plus 6 greater than or equal to 0, okay? And this is equivalent to, let's simplify the numerator here. 3x minus 8 plus 9 times 7x, which is 63x, right? And 9 times 6 is 54, right? Over 7x plus 6, which is greater than or equal to 0. And this is equivalent to 3x plus 63x, which is 66x. And 54 minus 8 is 46, right? Over 7x minus 6, which is greater than or equal to 0. And note here, 66 and 46, there is a common factor 2, right? So we can divide both sides using a 2. And because 2 is positive number, when you divide both sides using a positive number, we don't change direction of an inequality symbol, right? Okay, left-hand side divided by 2 is 33x plus 23 over 7x plus 6. Right-hand side, 0 over 2 is, of course, also 0, right? And do not change the inequality symbol because 2 is positive. Okay, now the original expression is equivalent to, first of all, we have an equation. 33x plus 23 over 7x plus 6 is 0. Or this ratio can also be greater than 0, right? So we have successfully detached this problem into an equation and an inequality. Okay. For the equation, if you have a ratio that is 0, that means the numerator must be 0. And at the same time, the denominator cannot be 0, right? Or for the inequality, we have already know how to solve this. You have a ratio that is a positive number. That means both of the two numbers have the same sign. Either we will have a positive numerator and at the same time a positive denominator, or both of the numerator and denominator are negative, right? Okay, both of the two numbers here are negative. Okay, so there are 3 branches. Let's solve them one by one. First is equation. Equation gives us x. First, x must be minus 23 over 33, and x cannot be minus 6 over 7, right? Or second branch gives us x must be greater than minus 23 over 33, and x must also be greater than minus 6 over 7, right? Or third branch. First of all, x should be smaller than minus 23 over 33, and x must be smaller than minus 6 over 7. Now we need to compare these two numbers, which is larger, right? First number is about minus 0.6, something. Second number is about minus 0.8 something. So which number is larger? Of course, we draw a number axis if this number is minus 23 over 33. This number is larger, right? And minus 6 over 7 must be on the left of the minus 23 over 33. Okay, so let's combine the three solutions here. First of all, x can be minus 23 over 33. Second branch is x must be greater than both of the two numbers. Combined result is x must be greater than the greater number, which is minus 23 over 33, right? Third branch is x must be smaller than both those two numbers. So x, the overlapped area is x must be smaller than the smaller number. Okay, so the final result, by combining all the three branches, final result is x is either greater than or equal to minus 23 over 33, or x is less than minus 6 over 7. Okay. This is the final result. Okay, please have a look at this. Do you have any questions? No? Okay, let's see next one. Okay, question 8. All right, this time let's move the expression on the left-hand side to the, on the right-hand side to the other side. So original expression, original inequality is equivalent to minus 12x over x plus 3 plus x plus 3, right? Smaller than or equal to 0. And this is equivalent to, let's rewrite the expression on the left-hand side using common denominator, which is x plus 3. So minus 12x over x plus 3 times x plus 3 times x plus 3 over x plus 3. This should be smaller than or equal to 0, right? Okay. Then this is equivalent to minus 12x plus x plus 3 squared, right? Over x plus 3. Smaller than or equal to 0. And then let's expand the numerator here. Minus 12x. Remember there is a formula to expand the x plus 3 squared. This is x squared plus twice of x and 3, which is 6x, right? Plus 9 over x plus 3, smaller than or equal to 0, okay? And this is equivalent to x squared minus 6x plus 9. This is also a formula, right? Which can be rewrite to x minus 3 squared, right? X minus 3 squared is x squared minus twice of x and 3, which is minus 6x plus 9. Okay, over x plus 3 smaller than or equal to 0, right? Okay, so this is equivalent to, first of all, the ratio here can be 0. Or it can also be smaller than 0. Right? And this is equivalent to, first of all, this equation is equivalent to the numerator must be 0 and the denominator cannot be 0, right? Or the inequality is equivalent to, when you have a ratio that is a negative number, that means the signs in front of the two numbers, the denominator and the numerator must be different, right? So we either have a negative numerator and at the same time a positive denominator, or we can have a positive numerator and at the same time a negative denominator, right? Okay, next let's solve the 3 branches one by one. First of all, when you have something squared equals 0, that means the thing here must be 0, right? So the solution is obvious, is x equals 3. And at the same time, as x cannot be minus 3. This is the solution for the equation, right? Or the second branch tells us that something squared is a negative number. So this cannot happen, right? No matter what x is, x plus 3 squared must be a non-negative number. So the second branch has no solution. That means x belongs to an empty set for the second branch. Or the third branch tells us, first of all, something squared that is greater than 0. So what is the solution of this? Okay, I'm going to ask you this question. Dora, tell me, what is the solution of this expression? So x minus 3 squared is greater than 0. What is the solution? You're saying x should be greater than 3, right? So, for example, x is 4, 5, 6. Of course, this will do. But how about minus 4? Or 2? Or 1? Will this number do? You know why? Minus 4 minus 3 squared equals minus 7 squared, which is 49, right? 49 is, of course, greater than 0. Do you see that? So can x be less than 3? Why? Because minus 4 is less than 3. So what is the solution? You have something squared greater than 0. What is the solution here? As long as this number is not 0, this is always greater than 0. Do you see that? So can you tell me what is the solution here? Okay, let me ask you, can x be 3? No, why? Because when x is 3, 3 minus 3 is 0, right? 0 squared is 0. It cannot be greater than 0, right? So the answer is no. So next question, can x be greater than 0, than 3? Yes, because when x is greater than 3, something greater than 3 minus 3 is always a positive number. So positive number squared is also a positive number, right? Next question, can x be smaller than 3? Yes, the answer is yes. Why? Because when x is smaller than 3, that means x minus 3 is a negative number, right? For any negative number, its squared is a positive number, which means this is greater than 0, right? So by considering all of these, what is the solution of the inequality here? You says x cannot be 3, but x can above 3 or less than 3. So this means as long as x is not 3, this is okay, right? Do you see that? So what is the solution of the third inequality? How do you express this in mathematical form? Can x be any real number? No. Which number it cannot be? I mean x, not x minus 3. So x, the only number x cannot be is 3, right? So the solution of the inequality must be x can be any number, but x cannot be 3, right? Do you see that? Both of you. This is the solution of this inequality. Okay, I need to ensure you really understand this. Okay, Emily says yes. How about Dora? Yes, okay. So next time when you meet this question, please ensure the solution is not x greater than 3, okay? Instead, the solution is any number but not 3, okay? So how about the second one? Second one is easier, right? X plus 3 is less than 0. When you move 3 to the other side, that becomes x is less than minus 3, right? Okay, so here x less than minus 3. Okay, so now, of course, 3 is larger and minus 3 is smaller, right? Okay, let's combine all the results here. First of all, x can be number 3. This is the first branch, right? Or second branch says x belongs to an empty set. That means there's no solution in the second branch. Third branch says x must be less than minus 3. and x cannot be 3, right? Okay, so what is the final result? By combining all of these, the final result is x is smaller than minus 3, or x can be 3, right? Any questions? All right, let's see the next one. You don't have any questions? Next question. What is a possible range of k such that this system of inequalities has no solutions for x? So first of all, let's try to solve it, okay? It says minus 6x should be greater than 7k plus 2. That means when we divide both sides using minus 6, you need to change the inequality symbol, right? This is equivalent to, okay, so let's call it star. System star is equivalent to x is smaller than 7k plus 2 minus 6. And also x should be greater than 4k plus 6 over 7, right? So let's call this m1, and second number is m2. The solution is x should be smaller than m1 and greater than m2. So under what circumstance there is no solution for x? If m1 is here and m2 is here, is there any solution for this system? In this situation, x is smaller than m1, larger than m2, there is no overlapped area. So in this situation, there's no solution, right? Okay, so if, let's say, m1, if m1 is smaller than m2, there is no solution, right? Okay, there is another question. Can m1 be m2? Can m1 and m2 are equal? Okay, tell me, both of you, tell me, can m1 and m2 be equal? Can we put the equality sign here? Emily says yes, and Dora says no. So if the two numbers are equal, that means m1 is here, m2 is also here, right? And the solution says x must be smaller than this number, and at the same time, greater than this number, right? So is there any solution in this case, Dora? So Dora, tell me, can the two numbers be equal? If the two numbers are equal, is there any solution for x? There is also no solution for x, right? So of course, the two numbers can be equal. So pay attention to the corner case. Okay, so this means, let's call this 2 stars. 2 stars. If the 2 stars is satisfied, there is no solution. 2 stars is equivalent to m1 is 7k plus 2 over minus 6. Smaller than or equal to m2. m2 is 4k plus 6 over 7, right? We only need to solve this inequality. Okay, this time we need to time minus 42 to both sides, right? Because 42 is the least common multiple of 6 and 7. So when you multiply the minus 42 to both sides, what will happen? You need to change the direction of the inequality symbol, right? Because minus 42 is a negative number. When you multiply a negative number to both sides, remember to change the direction of the inequality symbol. Okay, and this is equivalent to, you can then simplify both sides. 7 times 7k plus 2 greater than or equal to minus 6 times 4k plus 6, right? And this is equivalent to 49k plus 14 greater than or equal to minus 24k minus 36, which is equivalent to 73k greater than or equal to minus 50, right? So k should be greater than or equal to minus 50 over 73, right? Okay, so the conclusion is if k is greater than or equal to minus 50 over 73, no solution for x, right? Okay, have a look at this. Any questions? No? All right, let's see the next one. Okay, again, what is the possible range of M such that the system of inequalities has no solution for X? Okay, first of all, let's try to solve this system. Let's call this stars. System star is equivalent to X must be greater than or equal to 3m minus 5 over 2, right? And also X, so note here when you divide both sides using minus 4, you need to change the direction of the inequality symbol over minus 4. This is our solution, right? So let's call this K1 and K2. So tell me, under what circumstance there is no solution for X? The relative positions of K1 and K2 must be, so for example, K1 is here. Where should be K2? Tell me, on the left or right of K1? So let's say this is K1. Tell me where should K2 be? Should be to the left or to the right of K1? Both of you. Okay, this is a question for you. Should be here or here to make no solution for X. Okay, Emily says should be on the right, right? So you said K2 should be to the right of K1, right? So in this case, x is larger than or equal to k1, and x should also be smaller than or equal to k2. So the solution is here, right? There is solution for x in this case, which means k2 cannot be to the right of k1, right? So I want you to rethink this problem. Tell me, if k1 is here, where should be k2? Should be here or here? Dora? If you don't know the answer, you can just try, right? If k1 is to the left of k2, or in other words, if k2 is to the left of k1, what will happen? This is the first case, and this is the second case, right? In the first case, the inequality says x is greater than k1, less than k2. Of course, there is an overlapped area. This is the solution for x, right? And in the second case, x is larger than k1. That means x should be here. And x should be smaller than k2. That means x must be here, right? So is there any overlapped area in this case? No, right? So what are the relative positions of k1 and k2? Tell me. So k2 must be to the left, right? Okay, so I hope you really understand it. So this is the correct relative positions of k1 and k2, right? So the conclusion is if k2 is smaller than k1, there is no solution for x, right? This is your answer. But there is a corner case. Can k2 be equal to k1? I need you to think of this problem. Can we put an equality sign here? If k1 is equals k2, that means k1, k2 should be the same number, right? And system of inequalities says x is larger than or equal to this number. And x is smaller than or equal to this number, right? There is a solution to this system, which is x can be this number, right? So here we cannot let k1 equals k2 to ensure there is no solution for x. Understand? Emily, do you understand? Okay, so next time, please pay attention to the corner case, okay? Okay, let's call this 2 stars then. And we know that if 2 stars is satisfied, there is no solution for x. 2 stars is equivalent to k2. k2 is minus 8m plus 7 minus over minus 4. Less than k1. k1 is 3m minus 5 over 2, right? And all we need to do is to solve this inequality. So this is equivalent to tell me what is the next step. You can time both sides using a 4, right? 4 is the least common multiple. So let's time a 4 to both sides. Because usually I don't like to multiply both sides using a negative number. So this time let's multiply 4 to both sides. Left-hand side becomes this, and right-hand side becomes this, right? And this is equivalent to, sorry, I lost a negative sign here. And here, 4 cancels with -4, which left us a -1, right? So minus 8m plus 7, less than 2 times 3m minus 5. Okay, this is equivalent to 8m minus 7 less than 6m minus 10, right? And this is equivalent to 2m less than minus 3, right? Which means x is less than minus 3 over 2, right? So the solution is if m is less than minus 3 over 2, no solution for x. You get it? Okay, any questions? Okay, so pay attention to the whole analysis process after the class. I hope you can read through all my lecture notes, okay? And okay, last question. Again, what is the possible range of n such that this system has no solution for x? Again, let's call this star. First of all, let's try to solve this system. Star is equivalent to, first, x must be smaller than 6n plus 2 over 5. And x must also be, let's divide both sides using -6. So this time we need to change the inequality symbol because -6 is negative number, right? 5n minus 4 over -6. So let's call this k1, and this number is k2. And this time, tell me, suppose this is k1. Tell me where should k2 be? Should it be on to the left side of k1 or to the right? Which is the correct position of k2? In order to make the system has no solutions for x. Okay, both of you. Left or right? Okay, Emily gave me an answer. How about Dora? Okay, you have different answers. Okay, so let's check one by one, okay? If K1 is here, K2 is here, what will happen? System says X should be smaller than K1, right? And X is also greater than K2. So under this circumstance, is there a solution for X? No solution, right? In this situation, there's no solution. Whereas if K2 is to the left of K1, the system says X must be smaller than or equal to K1. And X must be greater than K2. So is there any overlapped area? Of course, here is your solution, right? So in this situation, there does have solution for X. So which is the correct option, left or right? K2 should be to the left of K1 or to the right of K1. Dora? Right. Okay. They correct that this time. This is a correct relative position, right? So K2 must be to the right of K1. In this case, there is no solution for X, right? So let's say if K1 is smaller than K2, no solutions for X, right? So another problem is, can we put an equality sign here? This is a corner case, you can't miss, right? Can we do this? This time, can we do this? Tell me. What will happen if K1 equals K2? How about Dora? Can you tell me? Yes, we can, right? If K1 equals K2, this means both K1 and K2 here. So in this case, the original system says X must be smaller than or equal to K1. And at the same time, X must be greater than K2, right? So is there any overlapped area? Of course, there is not. So in this case, there is also no solution for X. So of course, K1 can equal to K2. In this circumstance, there is also no solution for X. Okay, so let's call this 2 stars. 2 stars is equivalent to, okay, K1 is 6n plus 2 over 5. Smaller than or equal to K2. K2 is 5n minus 4 over minus 6, right? And this time we can multiply both sides using their least common multiple, which is 30, right? So this is equivalent to left-hand side becomes 6 times 6n plus 2, smaller than or equal to minus 5n minus 2, right? Minus 4, which is equivalent to 36n plus 12, smaller than or equal to minus 25n plus 20, right? Okay, so this is equivalent to, okay, 36 plus 25 is 61n, smaller than or equal to 20 minus 12 is 8. So this is equivalent to n must be smaller than or equal to 8 over 61. Okay, now the conclusion is if n is smaller than or equal to 8 over 61, there is no solution. For X. Okay, I hope you do understand the whole reasoning process, right? Okay, so do you have any questions to ask? All right, I've put my notes onto Google Classroom. Please do read through my notes and correct your assignment, okay? And next assignment, I think we need to try something new. For example, to draw the diagram of the inequalities, okay? And I'll upload the new assignment as soon as possible. I'll let you know when it's available, okay? If you don't have any questions, you're free to leave. Okay. Have a nice weekend.